good afternoon. My name is Abiola Oyeniyi. I am many things, but currently the technical director of Python Nigeria and also the co-founder of Tutorial Limited. So today we would be talking about Lightning addresses. So before I start, just want to ask who knows anything about, or who has heard anything about Lightning in the audience right now? Okay, well, obviously my slide has already given a hint. Enhancing Bitcoin Lightning Network for seamless payment. Now, to understand what this talk is about, first needs to understand Bitcoin. Who has heard about Bitcoin here? Why are we, has everybody heard about Bitcoin, or is only very few of us? Okay, and so I'll just talk a bit about it. Bitcoin is a decentralized digital currency. The reason why it exists is to solve a specific problem of transfer without third parties. And not to go too much into the economic impact, also because it's a decentralized means of value transfer, monetary transfer, to a large extent, the transactions are pseudonymous. You can see I used the word pseudonymous, I didn't use anonymous. They mean two completely different things. The transactions are not completely untraceable because it's just they are kind of pseudonymous. Pseudonymous is, you could think of pseudonymous as they don't necessarily contain your identity, but depending on how you interact with the platform, your identity could be linked to that transaction. Now, one of the major complaints of again, Bitcoin is it's built on a number of technologies, makes use of blockchains. One major issue with blockchains is they are slow, and that's not necessarily a fault of blockchain. That's because of the nature of the problem you're trying to solve with blockchain. Again, we're solving the ability to transfer funds in a decentralized manner, to transfer value in a decentralized manner, and without a central third party. And in order to do that, it works with a consensus mechanism. So you have the concept of nodes around the network that would need to validate and ensure that every transaction that propagates within the network, they obey some set of rules that have been defined or that has been agreed upon by the software you're running. And in order to pull that off, that in a way is what contributes to the delay, to the slowness of transaction verification. So that is a compromise that actually exists at the Bitcoin layer. But obviously, for day-to-day commerce, that's not acceptable. It becomes an issue if I'm looking to transact with you and I have to wait approximately 10 minutes before my transaction, you get to see that my transaction is confirmed. And in order to address that, and also in addition to that, we also have issues around transaction fees. Even though right now it's actually very cheap to transfer Bitcoin because it's actually cheap right now. Just take my word for it, or you could just go to a block explorer to see how much it's going to cost. But there are times when the fees are always very high. And in a country like Nigeria, where we're obviously suffering from inflation, you don't want to end up spending the actual amount you're looking to send on fees. So this is where layer 2 solutions come into play. And again, there are other blockchains, but I'm mostly focused on Bitcoin. And one of the most promising layer 2 solution on Bitcoin is the Lightning Network. The Lightning Network is actually broad, but I'm actually going to be focusing on a very specific property of the Lightning Network, which is basically Lightning addresses. Now, for anyone that's actually done a Bitcoin or a blockchain transaction, one of the key attributes is the recipient needs to know an address, right? You need to send an address to the recipient. Also, the sender to a large extent, also needs to impute the amount they need to send, and then that happens. So there's kind of like a series of steps. Ahead of time, the sender needs to know who is sending the payment to, and he needs to have the address of that user. And because of nature of transactions on blockchain, as in the receiver could have multiple addresses, could have thousands of addresses, millions of addresses. So while that's fine, what the Lightning address is looking to achieve is a way whereby everyone is familiar with the email, with the email format, right? Everyone, obviously, I would assume everyone has an email here. So a way to using an email format as an identifier to a recipient. So what that means is, instead of, if I wanted to send a payment to you, instead of asking you for an actual address, again, I just ask you for an email. As in, again, it doesn't necessarily have to be an actual email, but every user ends up with an identifier that looks like an email. And that, to a large extent, building on top of certain protocols that exist, which I will talk about in a bit, simplifies the transfer payment process. Now, like I said, the main purpose of Lightning addresses is to simplify the user experience of payment and also abstract all the technical complexities of the Lightning invoice, of our Lightning, of Lightning invoices. Again, like I said, the Lightning Network is a layer 2 solution. Unlike the Bitcoin, so Bitcoin is the layer 1 solution, the Lightning Network is a layer 2 solution. You can liken it to something like our interaction with banks. You can think of it as a layer 2 solution. And then banks' interactions with the central bank, you can think of it as a layer 1 solution. So you know every bank has to have a reserve set up, and then banks need to transfer funds, as in there's that movement of funds that happen at the bank layer, which is obviously different from when we're trying to transfer funds from a bank account to another bank account on an individual basis. So you could use the same analogy in explaining layer 1 and layer 2 solutions. Now, what are the benefits of Lightning addresses? It's user-friendly. You don't need to memorize complex invoice code. You just need to know the Lightning address you're sending it to. And it greatly reduces friction for onboarding new users. I can imagine a lot of us here will probably be very skeptical of anything involving blockchain because of all the news that we've probably heard. But it does have its use because, again, it's a permissionless system. You don't need a bank account. Anyone can use the platform and use it to receive value for whatever business you're into, whatever skill set you have. If it's something that provides value, anyone can pay you with it. And also, in fact, one other major benefit is the fact that privacy is greatly improved. Like I said, one drawback with transacting on-chain is the fact that your identity could be tied to your transaction, which normally it's not a problem, but it can be abused. So it's always good. It's not always all transactions that you want to be publicly accessible. As in, you can imagine, using an actual example that happened here during the protest that happened, was it 4 years ago? And a number of people's bank accounts were closed. So that's one advantage of transacting on the second layer. Now, again, this talk is technical. I just basically talked about some introduction. But how do we pull this off? And this is based off a standard, a protocol standard that operates on the Lightning Network, which is known as LNURL. And basically, how it works is the user enters a Lightning address. Again, the Lightning address is basically an email format, so it could be a username at the domain where the backend is hosted. And then there is a specific endpoint on that domain that is exposed, that is listening for that. Again, the wallet knows how to translate that Lightning address to, it knows how to pull out who the username is, and then it's able to construct that username into a specific URL path. And then from that URL path, it is making a call to the domain that is attached to that Lightning address. And then, because again, you are calling a specific server, the server obviously knows how to generate the invoice that is required in order for that payment to be made. And there are a few interesting things that could happen. Because the server is the one generating the invoice, the server could also add additional metadata information like the amount that is to be paid. The receiver does not need to know, the person that is supposed to make the payment does not need to know what that is. All that information is automatically embedded in the invoice generation, and then the only thing the user just needs to do is just to make payment. And so, again, just to buttress the point I made previously, you need to set up an LN URL compatible backend. Again, nothing too complex about it. It's just, you just need to ensure that there are a few set of endpoints you need to expose on your backend. And also your backend needs to be able to generate an invoice. And you can either use a self-hosting platform to do that, or you can actually set up one yourself. It's not too difficult. I'll probably talk a bit about it. On the front end, again, if you're a wallet developer, you just need to ensure that the wallet you are building also understands the Lightning address protocol. Because again, from a wallet standpoint, you are probably scanning a QR code, which consists of the email format, and then you're able to translate that email format in order to generate the endpoint that you need to make to the server. Again, the endpoint is fairly defined, as in it's part of a standard. And then as long as you're able to do that, the server is able to respond to that API call and carry out whatsoever respective actions that needs to happen. The good thing about this is there are a number of Lightning addresses that currently exist at the moment. We've got Blue Wallet, we've got Phoenix, we've got Wallet of Satoshi. There are quite a number of them, and a number of them already do support this protocol. Okay, so there are some technical considerations to consider, especially when implementing a backend that supports Lightning addresses or LN URL in general. And that's it. Obviously, you can only make those calls through an SSL TLS connection. So what that means is, if you're going to be using HTTP as a transport layer, you need to have an SSL certificate in place, because again, that needs to be in place. Or alternatively, if you don't have an SSL TLS certificate, you can also use the Tor Onion routing solution. So I don't know who is familiar with Tor, as in the Tor network. You know, Tor is a privacy enhancing network. Again, it mostly runs on HTTP, but you've got a completely different network system. So that could also be used as a transport layer when translating the Lightning address into a format that can be responded to by the server. Now, what are some of the practical use cases for Lightning payments in general? E-commerce. Merchants would obviously love solutions like this because, one, they don't necessarily need to care about chargebacks, and it's very easy for users to pay them, again, assuming the users are already making use of Lightning. Content monetization, again, because it's a layer 2 network, you are not constrained with the size of amount that you can receive. I can imagine right now, virtually nobody here is working with payment that maybe involves 1 naira, because 1 naira is literally worthless. But imagine a situation where maybe you're a content provider, you're a content provider, and you have a large following. Normally, those followers will not even pay you any money. In fact, the vast majority of content providers, most of your followers, especially if they are from Nigeria, won't pay you. But imagine you're able to get 1 naira from each of them. Obviously, that's always going to be difficult if they had to pay you their bank account with 1 naira, as in with the charges that bank currently charge. I think the minimum is 15 naira now. That is already no, that's obviously out of the way. But with the Lightning Network, that's a ball in the park. You can send the 1 naira as many times as you want, and the recipient receives it almost immediately. Can also be used for gaming and tipping in social network. It's also a very strong use case for the Lightning Network. Okay, I don't know if that text is visible. All right. So this is just a snippet of how to implement the endpoints on the back end. I'll probably talk a bit again. Like I said, there is a well-defined protocol that exists when you're trying to implement an LN URL backend. I pasted the link. Probably share the slides after the talk to find out more information about the steps that are required when you are trying to implement an LN URL backend. Again, you can see I'm not focused much on the front end because the assumption is you're probably using a wallet that's already compatible. In fact, the vast majority of the wallets that currently exist that are Bitcoin or Lightning native are already compatible with the protocol. It's just how to implement your servers to be able to leverage that functionality. So again, I'm using Django in this example, and in order to just reduce the amount of code I needed to paste, I put the URL part at the top to just match. So based off the URL, it translates this specific method is intercepting it, and it's translating the information. So again, like I said, the way the Lightning addresses work, it's like an email format, right? You can think of that email format as just an alias. The wallet knows how to translate that email address to this URL. So you can imagine if the Lightning address was, say, Abiola@example.com. What the wallet, when you type in that into the wallet is basically interpreting that and is generating a path where the main domain is example.com, and then it's calling the .well-known/lnurlp/Biola. That's kind of like the convention, and it's always a GET call. And then when the wallet makes that API call, you end up with a response that looks like this. Again, this is a standard response that is expected to be returned by the server when making a call. The metadata, you could add a lot more metadata, but the tag needs to consist of the pay request endpoint. The callback is basically the endpoint that will be called when the invoice is eventually sent. The min sendable and the max sendable is the amount that is expected to be sent. The wallet can always interpret that information and use that in determining the exact amount that needs to be sent to the server. And then, in addition to this, you could also, instead of, in the event where you don't want to deal with the actual email address, you could always embed it in a QR code. So that's also an option. And, sorry. And then for the actual logic, you are basically reading information from the Lightning address, and this is basically what generates the response that I showed previously. Now, when the wallet receives that response, again, it knows all the information that has been sent by the server. The wallet is able to generate the wallet has the invoice payment, so the wallet can actually make the payment. Again, imagine this scenario where the merchant is the owner of the server, you as a customer, you are the client. You typed in the merchant's Lightning address. The call is made to the merchant server. The merchant sends all those information. Your wallet reads those information and is able to determine the actual payment that needs to be made, and the payment just happens. The merchant receives the payment, your wallet has responded to the payment, and For any time you need to interact with the merchant, you probably don't even need to go to the site of the merchant. You already have the information of the merchant, and you can just do that. And that's basically how it works. Again, to get more information about how it works, I probably pasted some links on the slide. So if you notice in one of the links that I pasted, there was a callback URL that is part of the response from that is initially sent. The callback URL is basically the endpoint that the client, again, when I mean the client, I mean the actual wallet, needs to call when the payment needs to happen. And in that callback URL, chances are information about the invoice is sent, as well as the amount that was generated by the wallet. And then that specific endpoint is what actually carries out the payment. And I just put a screenshot of what it looks like, what the interface looks like. You can see I currently have, I don't know if it's visible, zooming it out a bit. Again, you can see from a wallet standpoint, you could basically just assign users to specific addresses, and then selecting a specific address, the information of the amount I need to pay. Again, there's nothing stopping the user of the wallet to change the amount. It's just, it has to be within the range, the acceptable range of what was specified by the wallet and by the call, by the API call that translated the Lightning address. So like in the example I pasted, you saw it was 20,000. So obviously if I put, again, that amount that was sent down is in millisatoshis. So just to clarify a bit, a satoshi is the smallest unit of the Bitcoin network, and 100 million satoshis is equal to a Bitcoin. So what that means is when operating with the with this LNURL protocol, because it's not exactly working in Satoshi unit, it's working in millisatoshis. So what that means, you need to divide the Satoshi unit by 1,000. So using this example in my wallet, I've got 100 sats specified, but what is actually being sent in the API call is 100 sats multiplied by 1,000, because millisats is what is expected. And then the payment just goes through. No need for figuring out, I need to generate an invoice, I need to send it to the server, and this can happen continuously anytime payment needs to be made. Again, I'm probably limiting this talk to just a single aspect of LNURL, because there are a number of, if you were to go to the protocol, it basically specifies a number of different scenarios by which you can actually improve the experience as it relates to receiving as well as spending. Right now, I'm mostly focused on the spending part, but there are also recommendations on some backend implementations you can do regarding receiving as well. So, again, it might appear this talk is a bit more specific to a specific blockchain, which is a big Bitcoin blockchain, but if you actually take a look at the protocol, you can realize that this is definitely something that can be extended across different blockchains. So you can imagine a scenario whereby, for someone like me, for example, I only care about Bitcoin, but I provide a good and service, and I have a Lightning address, and I want other people to be able to pay me. Obviously, there is an implicit assumption that anyone that needs to be able to pay me would need to be running a compatible Bitcoin wallet, which, again, that's the default scenario. But if I am receiving the payment, I'm able to make maybe a minor change to the protocol, where, because I know that, depending on the wallet of the user, if the user, anytime the user is reading my Lightning address, if, say, for example, it was a Solana wallet, for example, I'm able to detect that, okay, yes, I'm running on a different blockchain, and my server is able to identify that, okay, this is a different blockchain. I expect, I'm following the same convention, but I'm sending the information in a different form. But again, we're using the same standard, as in the same set of parameters, probably different units, because I don't know what other blockchain use as the smallest unit. But the point is, the information, we're using the same tag information, we're using the same minimum spend, we're using the same maximum spend, we're using the same callback. But depending on the wallet, because the wallet is what is translating the address in order to make the call, it means something different. So those are possible things that can be extended. Also, the funding source does not necessarily need to be a Lightning node. Again, when working with layer 2 solutions in general, especially if you're working in the blockchain crypto space, you probably need to be running a server that understands, that knows how to work on that layer and then can translate that at a specific point in time to the base chain, to the layer 1. And sometimes those servers, they call them nodes, they're not so much easy to run. But as software developers, again, we don't necessarily like stress, especially when it comes to especially when it comes to implementing solutions. So the funding source could just basically be, it could be a random API that can generate invoices, that can generate a payment solution. Can imagine some of the backend being maybe like an exchange. So even if you choose not to run a Lightning node, or you are not so much interested in Bitcoin, if you have an exchange, you've got access to the exchange, you can always use that as a funding source. And again, this is supposed to be just an introduction to development using the Lightning Network. If it's something that you're looking to dig into, you can always look at the proposals, the RFC proposals for the Lightning Network and some of the other tools that exist. And I also put some of the use cases that could be explored. But you can imagine scenarios where payment is not even just happening from the wallet. You don't even need access to the wallet in order to be able to pay someone. Those are things that become possible with protocols like this. And that would be all. Thank you. Any question? Probably you want to take very few because my time is up. Sure.
Okay. Yeah, hello. So I have two questions. So one is related to, so this is really similar to what ENS domain is, right? Where you create an identity for your address. So how do you ensure, or is there any provision for fraud where I'm creating my Elon Musk.btc or something? So what's the provision for that? Then my second question, so for fraud, right, it's very easy to create an identity called Elon Musk 1 or Elon Musk underscore dot or BTC or whatever. How are you managing that? Then, sorry. So is there also a provision for mistakes? So I'm trying to make a payment and, you know, I was given a Solana address and I'm trying to send BTC. How do you manage that? Is there a trigger to tell me I'm sending to the wrong address or I just lose my money?
All right, that's a good series of questions. Regarding the first one, again, what I just described is when you're trying to pay someone. So to a large extent, there's someone that is being paid. And chances are the domain is probably whosoever the payment, because you're going to be making a payment to someone, you probably receive the Lightning address from the merchant, for lack of a better word in this example. Now, the users, again, as long as the merchant is not, again, it boils down to if the merchant is malicious, because you're not just sending to anybody, you are sending to a specific user. So if you can imagine a scenario where you've got maybe a wrong user that is attached in the email format, that is obviously a problem from the merchant standpoint. So that merchant is a malicious merchant in that scenario, as in you are obviously transacting with a malicious merchant. It's just like you're trying to pay for a service. If the provider gives you a wrong, if it was a scammer, for does increase the complexity, but you are trying to solve a UX problem. And when you're solving a UX problem, you are absorbing a lot of the roadblocks in solving that. Hopefully, the answer I gave is a bit helpful. That'll be all. Thank you.
Thank you, Mr. Abiola. So next we are going to have another